just to go quickly through DesignPave. So DesignPave has actual two functionalities. The first is a structural design side, and the second is a permeable pavement design side. So in this webinar, we're just going to be focusing on the structural design, and of that structural design, just the structural design of roads. So moving into the DesignPave sectionality, we're doing a design, and of that, we have the option of doing a road or an industrial design. So in this instance, we're doing a road, and DesignPave is made in a way that makes the walkthrough simple and easy to understand, as you can obviously see right now. So we saw that Austroads is moving towards an average annual daily traffic kind of methodology. And to use that, we simply click it. To recreate the example, we had an estimated AADT of 20,000, and we had a directional split of 50%, meaning only 50% of the vehicles from the Wayne Merchant Survey were going in our design traffic lane or in the direction of our design traffic. Our lane directional factor was 1.0. We were assuming that our two-way road had no cars stopping. We had an annual traffic growth rate of 3% a year, and our service life was 30 years. The number of heavy vehicles we had was 3%, and our average heavy vehicle axle groups per those heavy vehicles was 2.5. And from the example, we assumed an ESA on HVAG, or ESA per heavy vehicle axle group, of about 0.9. So simply put, we had about 13 million vehicles moving along that road over its entire design life. And those 13 million vehicles created about 12 million ESAs worth of damage, which we would have to design for. So there's two options. I can use that ESA on heavy vehicle axle group to determine an equivalent number of ESAs. So if I use a CBR of 5, we can calculate it. And again, because we're converting all of our traffic loading into an ESA, we're making several assumptions. The most principal of those is that our tire radius is the contact area of our tire is 0.15 meters. Right? So if I did it, the standard ESA on HVAG methodology that Austroads shows, we get a design thickness of about 470. If I were to change that to use a traffic spectrum, the way a traffic spectrum works is it modifies, or it takes into consideration that large distribution of tire contact radiuses. So a 10 kilonewton tire would have a smaller radius than a 130 kilonewton axle. So when I do that, again, these axial values, we can input the ones that were provided to us from Austroads if we wish. I'm going to leave them here for now. So what you can do in DesignPave is you can either use the standard one provided to you by the CMAA. This was conducted by Brian Shackle, and this was the most representative Australian road at his Australian segmental paved road during his time. Or you have the option of loading a traffic spectrum in. All right. So I shared this to you previously, and you can select this file, you can open it up. And if I was to actually open up the file to just show you what I provided you, you can edit this file as you please, up to you in the end. But this is just the standard one provided by Austroads, right? And you can just change the numbers inside the file itself. So I can load that spectrum into DesignPave, and I can move forward with it. So remembering the value we got previously, which was via the assumptions made in Austroads for the ESA and the tire radius, we actually get a different value. And what this value is it's a more accurate representation of what your traffic spectrum does to that pavement. So this ensures it can either be more conservative or less conservative. It gives you that ability to make the correct decision. So again, having a weighing motion survey, your AADT, it's really useful when you're using DesignPave. And what this is doing is it's doing 340 simultaneous damage calculations to calculate a damage value that's less than 1. Yeah, that's essentially the road design functionality of DesignPave. So we've gone for AADT and the ability to use an ESA on HVAG or just a traffic spectrum.